Okay, here we are in the garage. Pay no attention to the man in the red shirt. I am about to mill some low-cost construction lumber to see if a 3-axis CNC can make a cabriole or Queen Anne leg. Here the CNC is a shop-built machine. The bed is 48 inches by 27 inches and the Z capacity is about 7 inches. The stock for this experiment is inexpensive spruce construction lumber. It's 2x4s that have been glued together and then carefully milled into a square shape with about 2.9 inches on a side. The feed rate of the machine as you see it now is about 60 inches per minute, which is relatively slow for a CNC machine, but I'm taking it easy for this first attempt. The router speed is 20,000 RPM. Before continuing the cutting, let's backtrack and review the steps that got us to this point. The first step is creating a computer model of the leg, and the second step is creating tool paths based on that model. The traditional method for making a cabriole leg involves a template of the leg silhouette. The leg silhouette is then traced onto the stock and cut on a bandsaw. Analogous to the traditional template is a sketch of the silhouette of the leg shown here. There are 3 templates shown. The smallest on the right is the one that was used to make a computer model for this experiment. Computer-aided design or CAD software used for this proof of concept project was Fusion 360. Here is the final computer model of the leg. It was surprisingly easy using the CAD software to create this model in Fusion from the template sketch. The blocks at the top and bottom of the leg will be used to register the stock in a holding jig for the CNC machining. These blocks will be cut off after project completion. After the computer model is completed, the next step is to create tool paths using CAM software. CAM, C-A-M, stands for Computer Aided Machining. Here we see the tool path representation for one of the sides. The CAM software also allows the tool paths to be simulated on the computer to confirm the program is cutting as intended. Here's a simulation of the first roughing cut on the top side. The leg will be milled in 4 different tool paths, 1 for each side of the leg. The tool paths are designed to be cut in a specific order. The faces are named top, bottom, back, and front based on the initial position of the stock. The tool paths are run in that order: first top, second the bottom, third the back, fourth the front, with the stock manually rotated between the running of each path. The first 2 paths are 2 steps. The first is an adaptive 3D clearing to within 0.2 of an inch of the final surface. The second stage is a parallel finishing cut to final depth with a 1/10 of an inch step over. The last 2 paths, being the stock side and the stock front, involve parallel finishing cuts only. Here is a computer simulated completed part. A close-up of the simulation actually shows the expected tool marks from the machining. At the end we will see how accurate this simulation is. This is the router bit used for the machining of both roughing and finishing passes. It is a solid carbide 1/2 inch ball end mill from Precision Tool Company. Here is the spruce stock held in a jig. The jig is made from MDF, which is clamped to the CNC table. The stock is securely held with 2 screws through the jig's uprights on each end. The stock is registered to the bottom of the jig and against the 2 blocks attached to the uprights. This simple arrangement makes easy release of the stock, rotation of the stock, and then reattachment in a known fixed position relative to the machine coordinate system. Here is a centering bit showing the 0 point of the work coordinate system. The 0 point for the work coordinate system for each face's toolpath is the top left front corner. The Z0 is actually the top of the stock. This way the machine does not have to be re-zeroed for each turn of the stock. Now back to the original cutting of the top face of the stock. Here is the result of the first or top side machining. The stock has been removed from the jig for this video shot. The tool marks are very close to what was predicted by the computer simulation. Here the stock has been remounted in the jig, this time with the bottom side now facing in the upward direction. To lessen wear and tear on the ball mill, I used the bandsaw to cut out the pieces which are laying next to the stock. This is the roughing pass on the bottom side. Note that the CNC's dust collection shoe is in position now. Now we have moved to the finishing parallel pass for the bottom side. This part of the video is sped up 4 times normal speed. Here is a shot of the bottom side after the finishing cut. This was the second side, 2 more to go. This is the parallel cutting of the third side, which is the back side. Only the first 2 sides require a roughing pass, followed by a finishing pass. Sides 3 and 4 use only finishing passes. This is the third or back side after its final tool pass. This is the fourth and final front side before machining. And here is the final result. This is the stock right off the machine without any scraping or sanding. An edge of the slipper foot did not survive machining and broke off. You can see the break here. This may be due to the poor quality construction lumber nature of the stock. The machine marks are surprisingly similar to the computer model simulation prediction. Total machining time was 62 minutes. The blocks at the top and bottom, of course, will be cut off. I expect to do this with a sled on a table saw. Handwork with a cabinet scraper and some sanding will be required to remove all tool marks. The tool marks can be lessened with a smaller step over in the finishing pass. In a subsequent experiment, I found that reducing the step over to 0.07 inches greatly reduced tool marks without adding too much to the cutting time. Thanks for watching.